Okay, let's solve a sample problem. We have here a point load of 50 kilonewtons is applied on the ground surface. Determine the subsurface stress at a point 3 meters below where the 50 kilonewton point load is applied using Boussinesq and Westergaard conditions. Also, we already have here the formula for the Boussinesq equation and then Westergaard equation. So to apply this formula, we will just refer to this given figure. Boussinesq equation and Westergaard equations are equations used to solve for the additional vertical stress to the effective stresses of soil caused by the load applied at the ground surface. So kung gusto natin mismo kunin yung epekto ng load na to sa point na to, we will just use Boussinesq or Westergaard equation. Yung point na kinoconsider habang lumalapit mismo sa point of application ng load, mas stress mismo yung point na yun. Habang lumalayo siya, nawawalan mismo ng epekto yung load na yan sa ating point na kinoconsider. Lumiliit mismo yung additional stress. Kasamahan mismo ito nung ating trapezoidal rule ng additional stress sa ating foundation, yung 1:2. Yung maglalagay ka ng trapezoidal, and then yung ating slope is 1 for the horizontal and 2 for the vertical. These are additional vertical stresses equations. Okay. So to apply the Boussinesq equation, kukunin lang natin mismo yung distance ng point na ina-analyze sa point of application ng ating load. By the way, these equations can be used only if the load applied is a point load. Pero pag ibang load na line load, hindi po pwede gamitin itong mga equations na yan. Okay. So, kunin lang kanyang x distance, y distance, and then z distance ng ating dalawang point na to. So, may pagka-mechanics. So, analyze nyo lang mismo yung figure natin. This will be our z distance, the depth of point A, and then this is our x distance. Ipo-project nyo dito, and then ito yung x distance, and then this is our y distance. Ipo-project nyo dito. Okay, back to our problem. As you can see in the figure, we only have a z distance. Yung x distance natin tsaka y distance is equivalent to 0. Since this point, say that is point A, is just directly below the point of application of Q, point load Q, which is 50 kilonewtons. So applying to our formula, x is 0, y is 0. If x is 0 and then y is 0, therefore R is equivalent to 0. So our additional vertical stress using Boussinesq condition is 3 times the point load, 50 kilonewtons, over 2 pi times z. The depth or z distance is 3 meters. Quantity squared multiplied by 1 plus r is 0 over 3. Quantity squared raised to 5/2. So apply nyo lang sa calculator nyo yan. And then we will get a value of 2.65 kilopascal. So the additional stress at this point caused by this load is 2.65 kilopascal. Okay, using Westergaard condition, so we will use this equation. Q, or the point load, is 50 kilonewtons over pi. Z is 3 meters. Quantity squared, 1 plus 2, r is 0, over 3 squared raised to 3/2. So apply nyo lang sa calculator niya yan, you will get an additional stress of 1.77 kilopascal. And this is Boussinesq and then Westergaard conditions for this given problem.